Hi everyone, I'm Gustav Rånby.
I'm Veeresh Elango.
We welcome you all to this presentation and let's get started.
Yep. How many of you have some kind of gardening experience? Maybe most of you might have some kind of gardening experience in your life. So when we plant a seed, we plant it with the huge dream of it becoming a tree so that it produces a long-lasting value. Well, do you think whether this would happen without any help from the nature or human? No. Maybe after certain fights it could grow, but it may not be producing a good value. Well, what is the thing that it needs? It needs the manure, fencing, proper rain, and so on. Well, you might ask, why are Veeresh taking a gardening session while discussing on the topic of DevOps? Well, they are related. We believe all these cool data-driven ideas are like those seeds, which we dream to become a long-lasting and valuable data product. Where DevOps is the process through which we ensure the continuous and faster development, maintainability, and reusability of the product. Well, you might also ask, do you have any example for this? Yes. We had a cool sustainability-based data-driven idea, which we converted into a long-lasting and value-producing product called as Shift to Electrification by Recommendation. And in this presentation, we will take you through the journey that we had while developing this application. Before getting into the application, let's look into the challenge that we are having in the transport industry. One of the biggest challenges as of now is how to convert this fuel-based vehicles into electrified vehicles so that they become more sustainable. You might wonder, yeah, just we could replace these fuel tanks with the big batteries. Yeah, kind of true, but is it possible just to fit a big battery? No, because these trucks are meant to carry the loads of weights. If you fill it with mostly with battery, they may not have a business. So we have to find the optimal battery size for each of these vehicles based upon their movement. So what we need to do first is to find the potential charging locations for each of this truck, through which we will be able to land upon the optimal battery sizes. But is it that enough? Can we, if we calculated the battery sizes, can we convert all our trucks into the electrified trucks on a single day? No. We need to have a plan so that when we could convert our whole fleet into the electrified trucks, so that our customer is also profitable. So these are the two key problems that we have solved within this application. Let's talk about the common process that happens in most of the industries and also happened with this application. A business person comes up with some requirement, whereas in this case, it was our customers are looking for converting their fleet into an electrified trucks. Do you have some idea? Data scientist thinks about it and says, maybe if I have this kind of data, I will be able to convert this data into a good calculations which could produce these results. And when he needs the data, he asks a DB guy. And this guy is a person who has immense knowledge on how these data are getting collected and where it is stored and how to take it out of the data lake. So he writes some kind of SQL query and just extracts the data and writes and converts it into an Excel sheet and delivers it to the data scientist. Whereas this data scientist receives the Excel sheet and do some kind of programming, Matlab or Python, whichever he's comfortable with, and do an export of Excel sheet and give it to the business person. So this is also a common thing that happened within this application also, which we need to convert into a valuable and long-lasting product. That's where we created a cross-function team to do this. And this team converted this cool data-driven sustainability-based idea into a valuable product within 12 weeks. And this is not a simple thing that it could happen. It was possible because this team had the good composure of all the skills needed to do this. And my colleague Gustav will take you through this journey of how we did this.
Thank you. So, what were we aiming for? We expect the demand for electrification to grow, so we need a solution that can scale when more customers are added. We want to create short feedback loops, and for that we need short response times, minutes instead of weeks. To present the result in a way that makes sense to the user, and we need a good user experience. The solution needs to be maintainable and allow for constant improvements and modifications as needs changes or are refined. At this point, we had an approximate idea about what we wanted to achieve. Scale and accelerate an existing method for battery configuration for electrical trucks. But what exactly was it? A website, an app, a Power BI report? And when we all gathered to figure this out, it turned out that the meetings weren't very efficient. 12 weeks is a short time if you fail to get started. We needed to align. We needed a plan. The basis for the project is the assumption that we can leverage on our connected vehicles and use historical movements for creating recommendations for electrification. We wanted to allow the user to experiment with different placements of infrastructure and to experiment with parameters like the estimated diesel price. The question was, how dynamic could we make the calculation? And by examining the different steps of the calculation, we concluded that a large part of the calculation can be done in advance and that the actual rollout plan can be calculated on the fly. The visualization of the rollout plan we decided to do in a JavaScript-based web application. The application allows the user to choose a charging infrastructure from a set of candidate placements, manually tune a set of parameters, and initiate the generation of a rollout plan. The rollout plan shows a suggested conversion time for each vehicle and shows how the total cost of ownership changes over time. It also shows the corresponding CO2 reduction. Let's summarize the high-level architecture. The data lake is responsible for cleaning and pre-processing the data in a scalable way. This is done by processing pipelines consisting of Spark jobs and Spark streaming jobs. AWS is suitable for the on-demand processing and services the backend. AWS allows for infrastructure as code and automated install and configuration. In the front end, the user can start an analysis and visualize and interact with the result. In this way, data from the vehicles are refined into information that is visualized in the front end, and this in turn gives knowledge and insights to the user. So, how does this actually happen? The user initiates a request for a rollout plan, and the request hits the backend Lambda. The backend Lambda is exposed via the API. The backend Lambda communicates with the rollout engine Lambda, and data is fetched from the data lake. The rollout plan is generated and returned to the front end, where it's visualized for the user. Before we dig into more details, let's brief ourselves on the principles of CICD. We start by building a self-contained package of the program, the build. We create a controlled environment for testing the build. We deploy the build to this test environment, and this is our first test, that we actually can deploy our program. The build is put through various tests, and if all tests pass, we have a release candidate. If they fail, we discard the build, and we never try to fix a failed build. Release candidates can be promoted and deployed to production. So, of course, this would be very tedious without automation. CICD is about repeatedly testing builds that are produced in the pipeline. And in order for these tests to be meaningful, we need a controlled environment. By adopting infrastructure as code, we can version control and reproducibly set up environments. In order to work in this development process, the team needs to adopt the DevOps culture, where responsibility for automation, testing, and installation is shared among the members of the team. So now, let's go into some detail, and we begin with the processing on the data lake. Our pipelines consist of transformation steps done by different Spark jobs. We use both batch jobs and streaming jobs. The heaviest lifting is done by the streaming jobs. The Spark jobs are version controlled in GitLab, and they are built and tested by Jenkins. Jenkins publishes the builds to a binary repository. The builds are put through various tests, and they are also integration tested. Builds that pass the tests are classified as release candidates. Finally, the released binaries are pulled by Airflow that runs the Spark streaming jobs on the data lake. Ansible is used for automating the install and for managing the configuration of the jobs. The Spark jobs can be seen as components, and batch jobs are run in the same way as Spark streaming jobs. This is achieved in part by encapsulating the jobs in Ansible playbooks that automates install and configuration. So let's continue with AWS, where we do the on-demand processing. And as we said earlier, one of the benefits of AWS is the capability for infrastructure as code. In order to make this fully automated and to utilize GitLab, we need to install a GitLab runner. The runner is set up using the infrastructure as code technology, CloudFormation. Now, with the GitLab runner in place, GitLab CICD can be used to set up lambdas in AWS. The lambdas and the registration in the API gateway is managed by the serverless framework. The same principle is used for installing the front end in CloudFront. So, with the heavy lifting of the data processing done in the data lake, and the front end and the back end installed in AWS, the user can configure and start an analysis. In this way, Scania can collaborate with customers and explore different options for electrification. Ultimately, DataOps, team spirit, and mixed competences got us to a happy ending. We managed to produce a minimum viable product in 12 weeks, and we won the Scania Analytics Award. All was not glory along the way, though. Communication is hard, even more so in a newly formed team of 17 people. Culture and mindset takes time to build, and we were lucky that we had similar ideas about how to work. The members of the team came from different parts of the organization and different organizational silos, and this made the decision process harder. Trust is key in every endeavor, and fortunately, we learned to trust each other along the way. Creating this information flow is not only about bridging technology. It's a lot about connecting people and bridging competences. UX, IT, big data, IoT, and data science. And last but not least, remember that in order to convert your cool data-driven idea into a long-lasting valuable product, we need DataOps to ensure fast and continuous development, maintainability, and reusability. Thank you.